Hello, this is Just a Jolt here, and we're going to be continuing on, checking my microphone was on. We're going to be continuing on today with the same GCSE Key Stage 4 level math stuff that we were doing yesterday. Now, the reason we're doing this is because if you're in year 11, well, it's probably kind of irrelevant to you. But if you like Just a Jolt, you can carry on watching. If you are below that year 9, 10 age, then you are 100% probably going to be sitting exams in this next year. So let's just get started. Last time we were looking at... I'll just go back here. Last time we were looking at some basic algebra stuff, and we're going to be kind of carrying on in that same vein today. So we're going to be using the website that I've been building especially to do this, and that at the moment is at justajolt.pythonanywhere.com. That's shortly going to change, so I've just brought a web address for it. Let's go to algebra. Let me choose. And we've been looking at some basic algebra stuff, namely yesterday we looked at dividing negative numbers, multiplying letters, and collecting like terms. So we're going to just have a few quick random questions on that to begin with. So simplify the following expression. Take some time to write this down. I'm going to write this down on the board. 9 plus 4 plus s plus sy plus s plus sy plus sy plus sy. You're going to see in just a second that my board really is too short for this. But anyway, so that's what we've got here. We've got 9 plus 4. Was that 9 plus 4 plus s plus sy plus s plus sy plus sy plus sy? So 3 sy's at the end there. And last time we talked about how that's an s, by the way, not a 5. Please don't get that mixed up. I have a student who gets his 9s and 4s mixed up because of how he writes them. Very important you don't get your numbers mixed up, otherwise you're not going to get the correct answer. So anyway, so to begin with, I'm going to collect all the numbers on one side and I'm going to collect all the letters on the other side. So I'm going to do this the slow way. If you're doing it the quick way, that's fine, but I'm going to do it the slow way. So sy plus sy plus sy plus sy plus s plus s plus 9 plus 4. So right there what I've done is I've collected together all of my numbers and all of my letters so that I can see how many of each I've got. Now, you might argue this is one step too many, but if you're just starting off with this, it is a good idea to collect them all together first before adding more stuff to them. So anyway, how many sy's have we got? 1, 2, 3, 4 sy. Can't see that at all, can you? Because this pen's absolutely awful. I did have a better pen yesterday. I'll see if I can spot it in the course of this. 4 sy, just like real school, isn't it, where the pens don't work. 4 sy plus 1, 2s plus... Now, with the 9 and 4, we can actually go right ahead and we can just go and add those together. That still looks like a 5, doesn't it? We can just go right ahead and we can add those together. So 9 plus 4 equals 13. And so our answer should be 4 sy plus 2s plus 13. And if we just go back to the website now, let's just see if we've got the correct answer. It might be in the different order. There you go. So you've got 2s plus 4 sy plus 13. Let's go ahead and generate another random question just to see how we do. So now we've got minus 20 divided by 5. So let's go ahead and do that. So minus 20 divided by 5. And yesterday we learned that if there is one minus in a sum like this, then the answer is also going to be negative. And so let's first of all just do straight 20 divided by 5. No negatives, no positives, no anything. 20 divided by 5 is, of course, 4. And because we've got a negative here, the answer is going to be negative 4. Let's do another one of these. So go back to the website, generate another one of these. Simplify this expression. Okay, now we're getting interesting. Now, we talked yesterday about the situation where you have x's looking like your multiplication symbol. And this is a prime example. So let's be careful about how we write our x's. Let's have x times x times t times t. Again, I'm writing that t very carefully so it doesn't look like a plus sign now. Right, so where do we go from here? Well, yesterday we talked about how, first of all, when you're dealing with letters, you can just go right ahead and you can actually get rid of these multiplication signs, because when you're dealing with letters, you really don't need them. So x, x, t, t. Is that my final answer? Well, no, not yet, because remember, we've got this situation right here where two x's, x times x, we can actually write that differently. 2 times 2 would be 2 squared, or 2 to the power of 2, and x times x, we can write that as x squared. So x squared dt. You could also write dx squared t, or dx or t x squared d. It really wouldn't matter. Let's just go back and let's check our answer. d squared td is what they've given us, and that's exactly the same as what we've got. The exact order of them really isn't that important. It's not that important. Okay, so let's go ahead and go for another one. By the way, if all you want to do is just use this website, go back to the website again, to practice rather than listen to me, then you go to GCSE Maths, and there's you can see the other kind of subject areas that I've been working on here. Anyway, we're going to go back to algebra, and we're going to go for what we're going to do. Let's go for some expanding brackets now. Now let's just start off with some single brackets questions, and we're going to use some letters. So I'm going to take some time to rub what I've got off the board. Off you go, using some highly valuable toilet paper to do that. This stuff is like absolute gold dust in the moment, isn't it? Actually, it's not. You'll get toilet paper quite easily if you want it. So, no need to panic buy. So, Z, we've got Z, J minus A. Now, I'm starting off with letters because it kind of illustrates the point that I'm going to make about expanding brackets here. And so, the way you expand brackets is really very simple. What you do is you multiply these two together. So Z times J, that's going to be ZJ as far as we're concerned. And then you have Z multiplied by A. And again, that's pretty easy, but it's not just Z multiplied by A, is it? It's Z multiplied by minus A, which means we're going to end up with minus ZA. Because remember, when you're multiplying, if one of the things you're multiplying is negative, then your answer is going to be negative as well. All right, so in this case, ZJ minus ZA. Let's go back to the website and just check that what we've said is correct. And there we go. That's exactly what we get. It's always reassuring when I manage to program things correctly. Anyway, let's do another one of these. So we've now got WF minus I. I love the combinations of letters here. So W, I think I'll just show you what I've got. WF minus I. And back we go again. So I've just been eating breakfast cereal. I've got some in my teeth. Do you not find that annoying? All right, so anyway, WF minus I. So right here, so W times F is going to be WF minus, WI is WI. Is it positive or negative? Well, you've got a negative here, and that's positive. So one negative means minus WI. Let's go back and let's check our answer, make sure it's correct. There you go. We got our answer there. Let's do one more of these, then we'll move on to something a bit more complicated, because I do want to try and give you a bit of value. So now we've got, let's write this up. We've got M R minus X. Lots of negatives here, which is interesting. That's just what the random kind of algorithmy sorts of things do sometimes. Right, so we've got M, R minus X. We're going to do the same again. So we've got M times R, MR, M times minus X, minus MX. And let's just check our answer, and let's make sure we've gotten that correct. There we go. Really, the only reason I'm checking the answer is to make sure that my programming is correct. I know it's the right answer, but we gotta make sure. Anyway, the next type of thing we're going to take a look at right here is we're going to introduce some numbers. So there we go. I've just randomized that again, so we've got another new question. The beauty of that website is that you can basically generate as many questions as you want to on any given topic. And eventually there's going to be the whole stinking math syllabus up there for you to use for your random exam question generating pleasure. As much practice as you want. And so S, and we've got X plus 7. Now we're going to do the same as before. S times X, which is going to be, that is an S, not a 5, right? Yeah, that is an S. It's going to be SX. And then S times 7, well, what's that going to be? Well, that's just going to be 7S. Is it positive or negative? Well, they're both positive. So SX plus 7S. Let's go ahead and just reveal that answer there. And that's exactly what we've got. The one thing I will say is that it's convention to have your number before the letter. And so if you were to write S7, that wouldn't really make any sense. So you've got to say the number and then the number of things you're talking about. And that's just the way we like to do things. Let's have another one of these. M5 plus M. Oh, this is getting interesting now. Look at this. M5 plus M. Right, so let's start off with our M5. M times 5 is going to give us, obviously, 5M. That's easy. And then plus M times M. What's that going to be? MM? M&M? Is that what it's going to be? No, it's not, because M times M, remember, is going to be an index number, isn't it? That's going to be, you're kind of squaring it, so we're going to end up with M squared. So again, we can go back and we can check that. There we go, and that's exactly what I've done. It's actually quite difficult to get a machine to do that, so I hope you appreciate that. Let's have another one. C2 plus 5. And again, we're just going to go right ahead and do this. So you can see this. That's what I'm working from. I've just randomized it again. And so you got C times 2 is going to be 2C plus 5C. And eventually it'll reach the case where you don't even have to think about it. You can just get on with it and do it, which is absolutely fantastic. So again, checking the answer there. And 2C plus 5C. There we go, that's reassuring. Right, now let's move on to having 2 brackets, and this is where things start to get a little bit more interesting. So I've just clicked the next button there, so that next button gives me the next kind of difficulty along, if you like, the next step. And so with each of these, you can choose to do, the next type, or you can have the previous type, and so it's really completely up to you there. But anyway, I'm just going to write this out. So we got D plus 4I, and then we got 7Y plus 5. Okay, now expanding one set of brackets is actually pretty simple. Expanding 2 sets of brackets is also pretty darn simple, and let me just show you why. We're going to start off with the first bracket, so D times 7Y. Well, there's already a letter there. What are we going to do about that? What are we going to do about this if there's already a letter? One of these numbers has already got a letter. What are we going to do? Well, we just whack it on the end. So you're going to end up with 7Y times D, 7YD. Nice and simple. Then let's have D times 5. Have plus 5D there. 4I times 7Y. So here we've got an interesting situation because we've got 2 numbers and 2 letters. Well, what we're going to do is, in turn, we're going to multiply. This is going to be plus, by the way, because they're both positive. And absence of a symbol there, means you just assume it's positive. And so you got 4 times 7, which is going to be 28. And then I times y, 28IY. Could I also write 28YI? YI? Yes, I could. If I was feeling Newcastle enough, I certainly could do that. All right, and then finally, let's have 4I times 5. That's right, 4I times 5. 4 times 5 is going to be 20. And let's not forget that we're also multiplying I in there as well. Let's now go back and make sure that I program this correctly. We've got 5D, 6DY, 20I, 28IY. Again, the order doesn't particularly matter. That's not too important. The important thing is that you've got all of the different elements there. Just realised I'm not plugged in, so I'm just going to plug the battery in right there. Otherwise, it will all stop working all of a sudden. I'll be kind of left in the dark. There we go. Plug that in. Oh, and there's the pen as well. There you go. There's the decent pen I was using yesterday. So look at that. That was worthwhile doing. That was worthwhile doing. Everything works out in the end. What just happened? Are you still there? You're still there. Okay, that's fine. Something crazy just happened, but it's all good. It's all good. Right, so that's that. Let's do one more of these, and then we'll move on again. We'll use the good pen this time. And now we have no letters at all. So I've just clicked this, and now we've got a situation where we have no letters whatsoever. Yep, no letters whatsoever. So we've got much better pen here. There we go. So we got 7 minus 2. 8 minus 6. So we've not only got no letters whatsoever, we've also got a thing where we've got 2 negatives. So that'll be interesting for us to work with. So first of all, 7 times 8. Well, 7 times 8. Oh, do you have any negatives here? Well, no, because there's no negative here. There's no negative here. And if there's no negative or positive there, you just assume it's positive. So let's have 7 times 8, which is going to be 56 in my reckoning. So you have 56 right there. And then the next one we're going to do is 7 times minus 6. So if you remember what we said before, to begin with, we're going to go ahead and just do 7 times 6. So 7 times 6 is going to be 42, the meaning of life. And if one of those is positive, if one of those is negative, sorry, then we also need to make it negative. So let's make that negative. Remember, one of these is negative, one of these is positive. Next one is minus 2 times 8. So minus 2 times 8. So again, there's one of these negative, one of these positive. I'm not going to bother kind of going through the step. I'm just going to do it now because we're getting pretty quick at that. And finally, we've got minus 2 times minus 6. Well, 2 times 6 is 12. Negative times negative is a positive. Now, is that our final answer? No, it's not. No, it's not. Because all of these are the same types of things. So we can simplify this, we can crunch all those together and come up with a final answer, which hopefully my program here reflects. So let's kind of see how that goes. So first of all, 56 minus 42 is going to give us 14, hopefully, if I've not been a total douche about this. Right, 14 minus 16 is going to give us minus 2. And then plus 12 should give us a final answer of 10. So when I go and click answer here, I'm looking for a final answer of 10. And that is exactly what I get, which is incredibly reassuring. Let's do just one more. Oh, this is interesting now. This is interesting. I'm going to make a little bit of space for myself while you guys are looking at that. There we go. So we got 7p. There it is, 7p plus n. And then we've got 7 minus 7. 7p plus c, 7 minus 7. So we can go back here now. Let's have a look and see what we've got. So we've got 7p times 7 to begin with. 7p times 7. Well, first of all, we're going to deal with those numbers. So 7 times 7 is going to be 49. So let's go ahead and write that to begin with. And we've also got a p there, so 49. It sounds like the price of a chocolate bar or something. Sounds like, sounds like the price of something that, used to be a lot less expensive. Anyway, like a 10p sweet that's gone up to 49p. And then we're going to do 7p times 7 again, which is going to mean we've got actually 49p once more. Oh, that's interesting. So now we've got two terms that are the same. We'll come back to that a bit later. Now let's have n times... but it's not going to be that, is it? Because it's going to be minus, because you've got 7p times minus that, and so that's going to be quite interesting. I wonder how my program's going to handle that. It might not handle it very well. We shall see. We shall see. All right, and now we've got n times 7. It's going to be 7n. And then we've got n times minus. Is that really what we've got? Yeah, n times minus 7, which is going to be minus 7n. Now we've got this situation here where I don't know how my website's going to handle this. You've got 49p minus 49p. Well, clearly that's 0. Plus, well, that's going to be 0 as well. So in theory, hopefully, my website should tell me that the answer here is 0, but I bet it doesn't. Oh, there you go, 0n plus 0p. That's not how I want it to be put, so I need to work on that. But actually, that's pretty darn good. Anyway, let's move on now. We've got another expand the brackets question for some reason. I'm not sure exactly why this is. There we go. So let's now see what we've got here. Do you know what? I think that might be all of our expand the brackets questions. So now let's move on to something else, because we've dealt with all of those different types to do with expanding brackets. And we're now going to deal with powers and indices. All right. Now, before we go on to powers and indices here, we need to just talk a little bit more about how all of that works. and we're going to talk about some of the rules to do with powers and indices. Now, the first thing I'm going to say is let's just make sure we know exactly what a power is. So let's make sure I'm on the screen. Yeah, I'm on the screen. So 2 times 2 is equal to 2 to the power of 2, which is 2 squared, which is equal to 4. So whenever you times a number by itself, then you can reference that, make it shorter, make it more pleasant to read, because mathematicians love to do that, by using an index right here. So this is known as an indices, all right? So let's take a look at something else. 2 times 2 times 2, 2 times 2 is 4 times 2, again, is 8. But we can also write that as 2 to the power of 3. And you can see there that actually writing this little 3 here is much, much nicer than writing 2 times 2 times 2. And we can go even further with that. 2 times 2 times 2. Well, if we times that 8 again, we get 16. And that's the same as writing 2 to the power of 4. And that's just much, much nicer. It's a much more pleasant way to write things. Now, we're not only restricted to numbers here, we can also use letters, which is what we love to do in algebra. So let's have y. Why not? So y just by itself, y times 1, if you like. We could also write y power of 1 there, because it's just kind of y, and that'll just be y. What about y times y? Well, you're probably seeing the pattern by now. We've got y squared, y times y times y. Now you've got y cubed, and you get the idea. That's exactly how it works. Now that we've looked at that, we're going to start looking at some more interesting powers rules, and there are basically 5 different rules that I want to cover initially to do with powers. After this, I'm going to stop. I'm going to have a break for myself, and then we'll come back and we'll do some advanced stuff to do with powers. Make some space on the board for myself to begin with. Really, I should have a bigger whiteboard, but I didn't anticipate doing this like a week ago. I never thought this was going to happen. But anyway, let's talk about an interesting situation where you're using a power of 0. What then? What if you multiply a number to the power of 0? What's all that about? Well, let's just have a little look, shall we? X to the power of 0. I'm not going to tell you why this is, because there's another amazing video which I can direct you to, which you can watch if you're super interested in this. Let me just go to YouTube, and let me just show you the reference for this video. This is the best explanation for multiplying by the power of 0 that I've ever seen. Right, I'm just going to type in power of 0, and I bet this comes up. I'm going to go to YouTube right now. So we've got, look at it, it's all coronavirus here. Power of 0 equals, here we go. It's this one right here, Eddie Woo. Eddie Woo. We're not going to watch the whole video, but this is the best explanation I've ever seen about why this is the case. But for now, please just take it from me that anything, the power of 0 is 1. Absolutely anything. It doesn't matter what it is. It can be 999 to the power of 0 is 1. Everything to the power of 0 is 1. Doesn't matter whether it's a letter, doesn't matter what it is. So y to the power of 0 is 1. All right, that's the first rule that I want you guys to know, is anything to the power of 0 is 1. Of course, I built a module onto my website reflecting this, so let's go back to here, power of 0. What is the value of 42 to the power of 0? It's all about the meaning of life, guys. 42 to the power of 0 is 1. Let's have another one. 57 to the power of 0, 1. B to the power of 0, 1. This was one of the easiest modules for me to program. Anyway, you get the idea. Anything to the power of 0 is 1. All right? Okay, next rule. Okay, anything to the power of 1, and we've kind of already covered this, is simply going to be itself. All right, anything to the power of 0 is anything to the power of 1, sorry, is simply going to be itself. Because it's really just if x times x is x squared, got two of them, then just x by itself is going to be x to the power of 1, which is just itself. All right, and again, we can just go and have a quick look at this. So 69 to the power of 1 is just going to be 69. 53 to the power of 1 is 53. 57 to the power of 1 is 57. M to the power of 1, excuse me, hiccups, is just m. 17 to the power of 1. So anything to the power of 1 is itself. To the power of 0, it's 1. Anything to the power of 1, though, is just itself. Okay, next rule. And by the way, I could also get there by going here. So 1 to the power of anything is also 1. All right? So let's take a look at this. 1 to the power of 87. Blimey, well, I'm not writing that. Absolutely not. But let's pretend that I was going to. Let's pretend that I was going to write that though. Let's say that I was about to write on this board 1 to the power of 87 out the way it should be written, and let's just see what happens. Right, 1 times 1 is 1 times 1, still 1 times 1. Still 1 times 1, still 1 times 1, it's still 1. It doesn't matter how many times I write this out. It doesn't matter. I could write this out 57 billion, million, trillion, gazillion times, and the answer is still going to be 1. Still going to be just 1. That's all it's going to be, just 1. So going, there we go. You actually didn't see any of that. I could write this out 1 times 1 time. I could write this as many times as I wanted to. The answer would still just be 1. All right? And just to, and there it is. The answer is 1. What's the answer going to be? 1. What's the answer going to be? 1. What's the answer going to be? 1. Let's try. Did not use any letters here. Maybe not. 1. 1. The answer is always, always, always going to be 1. Anyway, let's close these. Close that window, and what do we do? What do we have here? Close that window as well. Opens new window every time we do a thing. Anyway, now let's go to multiplying powers and see what we end up with. Well, this is an interesting situation, multiplying powers. So let's write that out, shall we? Let's have a to the power of 1 times a to the power of 5 times a to the power of 8. Well, let's just think about what we'd actually have here were we to do this. So let's have a to the power of 1, which is just a, plus a, multiplied by, times a times a times a times a times a, there's a lot of writing here, times a times a times a times a times a times a times a, 1, 2, 3, 4, 5, 6, 7 times a. So this is effectively what we're saying here, all right? And if we count now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If we were to count up to 14 here, you'll notice that this also adds up to 14. And so a shortcut we can take, rather than doing all of this, we could just write a to the power of 14, and that would be the correct answer. So let's take a look. A to the power of 14, let's have a look at another one. So 88, there we go. 88 to the power of 8 times 88 to the power of 4 times 88 to the power of 8. All right, so that's that written out. So we can do exactly the same with this. We haven't got to write it out all the times that it says here. We can just go right ahead and add these numbers up. So 88 plus 4, so that's 8 plus 4 plus 8, is going to be 88 to the power of 20. My goodness, I wonder how my website's going to handle that. It's just written 88 to the power of 20, which if you wanted to, you could punch that into your calculator. I chose not to do that for this program, but Really, I should have, really, that's what I should have done. Let's have another one. So 9 to the power of 5 times 9 to the power of 2 times 9 to the power of 3. And we're getting to the point now where we can just kind of do this in our heads. It's just simple adding up. So it's 9 to the power of 10. And again, I should probably have like calculated that for the answers, but you get the idea. You get the idea. Let's have a look at one more. And we've got 9 plus 7 plus 6. Oh, good heavens above. So that's 16, 22, 9 to the power of 32 to the power of 22. Sorry, there it is. All right. There's just one more thing that I really want to look at before I take a quick break. And so let's take a quick look at that. What happens in the event that you're dividing? Well, in the event that you're dividing, it's just the opposite of multiplying, right? So if you're dividing like this here, then really all you're saying is minus. So 15 minus 5 minus 6, and you're going to come up with an answer of hopefully 4. So you can have g to the power of 4. All right. Have another one. 14 minus 1 minus is going to be 27 to the power of 7, which if you wanted to, you could actually calculate. I've chosen not to. That's L to the power of, it's just going to be L to the power of 1, which is going to be L, really. That's going to be G to the power of 2. R to the power of 9. Oh, 7, sorry, because I can't count. And that's going to be 22 to the power of minus 6. It's going to be 16. It's going to be P to the power of 9. And you guys get the idea. All right, so I'm going to take a break and stop now. And tomorrow I'm going to move on to some more advanced rules for dealing with indices and dealing with surds, because that's interesting. All right. So anyway, this has been Mr. Jolt. If you've joined me, thanks very much for joining me for your daily dose of maths. If there is anything at all that you kind of think to yourself, actually, I'm not interested in algebra. I kind of want something else. If you decide that's the case, then please tell me, and we will 100% spend the time doing what you need to do. Like I say, if you're in year 11, I would say probably don't worry. You're not going to be sitting exams this year. If you're in years 9 or 10, then, you know, keep yourself warm. And if I can help to do that, making it more entertaining, if you'd rather watch me do it than, you know, than just doing work that school sent home from you, then I'm more than happy to help. If there are any questions that school sent home with you, anything that you're not sure about, because you are going to be sitting exams not this year, but next year. And remember, I'm not just doing this because I'm some randomer. I'm a physics with maths PGC qualified teacher with QTS with experience working in mainstream schools and all that kind of stuff. So anyway, this is Mr. Jolt signing off. Find the sign off button. Clickety